All right, guys, I hope we're excited to learn some math today. We're going to be learning how to complete the square. It means to make something into a square binomial. And what it's going to allow us to do is take quadratic equations and go directly into vertex form, so we'll be able to graph them easily. Before we get into doing that, we need to make sure we have some skills that we're supposed to already have coming in. Specifically, we really need to be able to square binomials. So let's see how you do on this. What is x minus 5 squared equal to? And hopefully we need this shortcut. There's a shortcut here that we need, which is that we need to know that when we have a binomial squared, we square the first term, so x squared is x squared. Then we multiply these two together. That's negative 5x. Negative 5 times x is negative 5x, and then multiply that times 2, and it gives us negative 10x. So we square the first one, multiply these two together, and then double it, and then we square the last one. Negative 5 times negative 5 is a positive 25. Whenever we square a binomial, we'll always end up with a positive at the end. And that's it. That's squaring a binomial. Go ahead and try another one on your own in case you maybe struggled on that. Go with x plus 8 squared. What is that one equal to? And hopefully you remembered and you were able to get it right. You square the first one. You multiply these two together. That's 8x. And double it. That will be 16x that gets added in. And then we square the last one. That's 64. Okay. Here we have a binomial being squared and multiplied. We need to make sure we do it in the right order of operations. Let's see how you guys do. We always do exponents before multiplying, so you cannot distribute this 2 right now. That would not be allowed. Instead, we need to square the binomial and leave the 2 alone multiplying on the outside. So the 2 is still going to be multiplying, but it's going to be multiplying by what this square binomial is equal to. So x plus 4 squared, we square the first term. Then we multiply these two together, that's 4x, and double it. That's 8x, that's the rule. And finally, we square the last one, which is 16. Last, because the 2 was multiplying times this, and this is now what this one is equal to, we now need to multiply the 2 times all of these. So we get 2x squared, and then plus 16x, and then plus 32. So that's a skill we should already have, is how to square a binomial. And today we're going to do a bit of a puzzle where you have to fill in the missing pieces. I think you're going to have fun with this. I hope you do at least. Find the missing term. What is the term that would make this equal to this square binomial? So x squared plus 8x plus what would give you x plus 4 squared? And this missing term should be 16. And I know that's true because when you square a binomial, you square the first one, x squared. These get multiplied together, which is 4x, and doubled, which makes 8x. And then you square the last one. So the last one needed to be 16. How about this next one? X squared plus what plus 49 would give you x plus 7 squared? Hopefully you were able to realize that this would be 14x. And the reason we know that is we square the first one, so x squared. We multiply these two together, that's 7x, and then double it, which would be 14x. And then we square the last one, which is the 49. So we do need to know, I guess I should have written this up here. Let's see what we're going to be using this whole time. If you have a binomial squared, the rule is you square the first one, multiply these two together, and then multiply that by 2. So you do these multiplied together, and then multiply that by 2, and then you square the last one. So that's the squaring a binomial shortcut that we're supposed to know, and we're going to be using all day. And so hopefully we can see that that's here. We're just going backwards. Okay, x squared plus 6x plus what gives us x plus what squared? There's 2 missing blanks here, but there's only one possible answer for what these 2 blanks have to be. Well, I hope you were able to figure this out, and if not, we'll figure it out together right now. The only way we could have gotten 6x is with the right number here. So we're going to actually figure out this number first, and then we'll come back and figure this one out. Because what's going on here is that this middle one is always what happens when you multiply these two together and double it. So what number needs to be here so that you can multiply these together and double it to get 6x? Well, it's 3, right? Because when you multiply 3 times x, that's 3x. doubled is 6x. So this needed to be a 3. An easy way to do it if you only have this one is to just divide this by 2. Whatever this middle one is, divide it by 2, and that's what number needs to go there. So x plus 3 squared. And now we can figure out what this missing number is. We square the first one, that's x squared. These get multiplied together and doubled to make this one. And then we square the last one. And so this needed to be 9. It's a bit of a puzzle. Why don't you try another one just like that? X squared minus 10x plus what equals x what? What's going to go here and here? Again, hopefully we can see that before we figure out this one, we need to figure out this part. And this part we can figure out based on what this is, because these will get multiplied together and doubled to make this. So it's like saying x times what times 2 will give you negative 10x. And the number that needs to go here is negative 5, right? X times negative 5 is negative 5x. Doubled would give you negative 10x. An easy way to do it is to divide by 2. So negative 10 divided by 2 has to be minus 5 or negative 5. That way when we multiply these two together, we get negative 5x. Doubled is negative 10x. And then when we square it, negative 5 times negative 5 is positive 25. So this must be a positive 25. So we can figure out both of those there. All right, a couple more. X squared minus 2x plus what equals x what squared? Hopefully you're starting to get the hang of this, that we can just divide this one by 2. Negative 2 divided by 2 is minus 1. And we know that because when we multiply these two together, that'll be negative 1x. Doubled will be negative 2x. And that's what we'll need to be able to use that shortcut. And so what number needs to go here? Well, this needs to be a positive 1 because negative times a negative is always a positive. So negative 1 squared, negative 1 times negative 1 is positive 1. And so it's x minus 2x plus 1. All right, this last one is super weird. 2x squared plus 8x plus what equals, and I just put a question mark here because like what's going on? How can this be a square binomial? Well, what it's not going to be is it's not going to be x plus something squared, because the first one when you square it would be x squared, not 2x squared. We need to do a trick here. When there's a number in front of the x squared, what we're going to do is we're going to factor it out. We're going to put 2 in front here. And so 2 times what will give us 2x squared? Well, now it's starting to look a little bit easier. 2 times x squared is 2x squared. 2 times what is 8x? Well, 2 times 4x is there. And now we can kind of see what's going on here. What it's going to equal is 2 times something squared. This 2 is just going to stay on the outside, and this we will turn into a square binomial. So you can answer this part. What does this square binomial have to be that will give us x squared plus 4x? And this has to be x plus 2. We know that because x squared will give us the x squared part, and these will multiply together and double to give us 4x. And so what's this last one going to be? Well, 2 squared is 4, and so that's what needed to be there. And so we can figure it out by factoring out the common factor in the front and then just leaving the 2 alone in front there. Why don't you guys try one of these on your own and see how you do? 3x squared plus 18x plus what will equal what involving a square binomial? And maybe you had trouble with this. It is a little trickier. When there's a number in front of the x squared, our method is we're first going to factor out the 3. So 3 times, well, what's left over? 3 times x squared gives us 3x squared. 3 times 6x gives us 18x. And so what is the number that's going to need to be here? Well, we'll figure that out in a second. But now I can see what the other side is going to be. The 3 is going to be on the outside, and I can tell what binomial squared it's going to be. It's going to be x plus, this gets divided by 2, 3. So x plus 3 squared. And I know this must be right because when I square the first one, it'll give me x squared. And when I multiply these two together and double it, it will give me 6x. So lastly, I can figure out what this guy is now, because if the 3 gets squared, that's going to have to be 9. So this is how we can deal with it if there's a number in front of the x squared. Now let's see what we're actually going to be using this for. This is a skill we should now have. We should be able to complete the square, and you guys can practice some a few times and make sure you can get it. But now we're going to use this, and what we're going to do is we're going to change from general form to vertex form. So what is the general form of a quadratic? Hopefully we remember. General form of a quadratic is when there's y equals ax squared plus bx plus c. This is a form of a quadratic, and we're going to change it into vertex form. Which one is the vertex form of a quadratic? Hopefully we remember that it's y equals, this is also called transformation form, y equals x minus h squared plus k. And here we're able to see that what the vertex is and graph it. The whole point of getting into vertex form is it's good for graphing. We might be able to graph it really easily. So let's see what's going on. This is in what form right now? Well, it's in general form. It's ax squared plus bx plus c. We can see the y-intercept. The y-intercept is 0, 3. And so if I wanted to graph it, I could say, okay, well, the y-intercept is going to be at 0, 3. But it's really hard to tell what's going on with the rest of it because we don't have where the vertex is. So here's what we're going to do. And guys, I am not pro-bullying, but we're going to do some bullying here. What we're going to do is we saw on the back that you could figure out how to complete the square, but what we really wanted is just these two parts. We don't want anything else there because we want to put the number we want to be there. Like we want to take x squared plus 6x and put the number we want to make the square. We take x squared minus 10x and put the 25 to complete the square. We always want to put a number there that we want. And so if there's already a number there, we are going to do something. This is not a math term, but we are going to bully out the y-intercept. We're going to tell it we don't like it. We don't want it around anymore. We want it to be gone. It needs to go its own way, and it's not part of our group anymore. And what this is going to look like is we're going to leave the other two terms in parentheses, and we're going to leave a space there, okay? And we're going to put the 3 outside of parentheses. What we're doing here is we're making room for that, that completing the square portion that we've done before. Okay, so now what we're going to do is we're going to rewrite this as a square binomial. So right below, we're going to put f of x equals, and we're going to rewrite this as what square binomial it has to be. And this is what we were practicing on the back. So what is the square binomial that has to work to give us x squared plus 6x plus something? And this one has to be x plus 3 squared, because x is getting squared. These are getting multiplied together and doubled to make this one. Again, you can just divide by 2 to figure out what number this needs to be. And now we can go back up. We need this to actually be equal to this one. So we need to finish putting the square in. Basically, we need it to, all of these need to be equal to each other. So this original one needs to equal this one, needs to equal this one. So if I want it to be a square binomial, I need to make it be a square binomial in the step above. Okay? So what number needs to be here to complete the square? Well, 3 squared is 9, and so I'm going to add in 9 here to make these equal to each other. But now, this is no longer equal to the one above it, and there's an easy way to fix that. This didn't used to have the plus 9. We added it in out of nowhere. And so to make it still equal to the one above, when we add in 9 out of nowhere, we subtract 9 also. So adding 9 and subtracting 9 isn't actually doing anything. It's still the same as the one above. Hopefully you can see that we've got x squared plus 6x plus 3 in both of these. And then if I add 9 and I subtract 9, it's still the same thing. But what I've done is I put the plus 9 inside the parentheses so I can make a square binomial. And what I'll do with these is I'll just combine them. And now I have a graph, an equation in vertex form. I've changed this into this. They're the same equation. One is in vertex form and one is not. And so, but they are equal to each other. For instance, if I plug in any number for x, I'll get the same answer out. Let's plug in 10. Let's do f of 10 here in this top one. F of 10 is going to be 10 squared, which is 100, plus 6 times 10, which is 60, plus 3, which is 163. If I plug into this bottom one, f of 10 will be equal to 10 plus 3 is 13. So 13 squared minus 6. 13 squared, 13 times 13 is 169. Minus 6 is 163. It's the same function, just written differently. But this one is in vertex form, and that gives me how to graph it. Where's the vertex? Where is the vertex for this, this graph? It's left by 3. Remember, for transformations, left and right is backwards from what you might think. This is 3 to the left and 6 down. And this is where the vertex is, and you can kind of see how it ends up hitting that y-intercept up above. If I wanted to actually graph the points, I would do 1 squared is 1, 2 squared is 4, and then 3 squared is 9. And that's where that's coming from. Okay. Let's try one more on your own. What about if we have y equals x squared minus 8x plus 1? Go ahead and try this on your own. What is this in vertex form? How do we change it to vertex form? And hopefully you recognize that what you can do here is complete the square. We're going to try to make it have a square binomial because it needs to look like this vertex form. So the first step, oh man, I didn't finish writing down my steps here. I'll write them out in a second when everybody is in the same place. The first step is to bully out the y-intercept. So we're going to say x squared minus 8x, and this is the y-intercept. We're just going to kick it out of the parentheses to make room for completing the square. Now, we're going to actually find what square binomial has to make this. So this is going to be some binomial squared. And so what is it going to be? Well, x, and this is going to be minus 4. And the reason I know it's minus 4 is because when I multiply these two together and double it, it has to give me negative 8x. I can just divide this by 2 to figure this out. Now, I can go back up and figure out what number needed to go there to actually make these equal to each other. So these need to be equal to each other. So we square the first one, that's x squared, multiply these two together and double it, that's the negative 8x, and now we square the last one. This is plus 16. If I add 16 out of nowhere, I need to subtract 16 to make it still equal to the original one. And then I can combine these terms and everything will still be, oops, minus 15. Everything will still be equal. I hope we can see that this is this binomial. This is this. And then up here, it's equal to the original one because I've got the plus 16 and the minus 16 canceling each other out. So it's still the same equation, just written in a different form. Where's the vertex for this? What is the vertex? And hopefully we recognize this would be 4 to the right and 15 down. So the vertex would be at 4, negative 15. Okay. Now I forgot earlier to finish writing out these steps. Let me write these out for you. Our first step is to bully out the y-intercept to make room for whatever square we're going to be completing. Okay. 2, figure out which square binomial we need. So figure out which square binomial we need. So after we bully it out, we're going to use the first one and the 2 first terms to figure out what square binomial it will be. We just divide the middle term by 2. So divide by 2 is how we're going to do that. And then we need to go back up and square the binomial and cancel out what you added in out of nowhere. So we're going to need to bully out the y-intercept to make room, figure out which square binomial it's going to be, complete the square by squaring the binomial, but whatever we add in, we need to subtract to cancel it out. Okay? So let's see. Why don't you guys practice one more of these on your own before we get a little bit harder. X squared plus 12x plus 17. Go ahead and complete the square on your own. And hopefully you were able to recognize that the first thing to do is to bully out this 17. We're going to make room to complete a square. So we're going to put the plus 17 outside the parentheses. Now, our next step is to figure out which square binomial we're going to need. So what square binomial is this? Well, I know it's going to be x because x squared will give me the x squared. These will multiply together and double to make this. So I can figure out what number this is by just dividing by 2. This is plus 6. Now I need to go back up. So what is x plus 6 equal to? X plus 6 squared equal to? Well, x squared These multiply together and double, and then we square the last one. So 6 squared is 36. If we add 36 out of nowhere, we need to subtract 36 to cancel it out. And then we can combine these like terms. 17 minus 36 is negative 19. And now I can tell what the vertex is and graph this. Where is the vertex? Well, it's at, oh man, I'm not going to graph this. It's going to be at negative 6, negative 19, because this is 6 to the left and 19 down. Remember, the left and right transformations are backwards from what you might think. All right, let's do an example together that's a little bit harder. H of x equals 2x squared plus 12x minus 1. First, why is this harder? What makes this one harder? Hopefully we notice it's because there's the 2x squared. So it's not just going to be x plus something squared, because x squared would be x squared, not 2x squared. Our steps will still be the same. We will bully out the y-intercept. So we're going to say h of x equals 2x squared plus 12x. We're going to leave room there to add something in, minus 1. But we're going to add in a second step that is different from before. So 2, if there's a number in front of the x squared, we need to factor out, and I'm going to call it a, from ax squared plus bx. So we're going to end up with something like this, where we have bullied out the y-intercept, and we're going to factor out the a. We need to pull it outside the parentheses so that we just have x squared. So let's do that. How do we factor this out? What's it going to be? Well, we're just going to factor out the 2. We're not factoring out the common factor. We're not factoring out the GCF. The GCF is actually 2x, but we just want to factor out the 2. We're just factoring out the coefficient. So 2 times x squared plus 6x minus 1. And now I can tell what square binomial it's going to be. So now all the other steps are going to be the same. So 3, figure out which binomial we need. So what binomial is this going to be? Now, the 2 is just going to have to be here on the outside, right? So the 2 is multiplying on the outside, but this will be a square binomial. So what square binomial is this going to need to be? This is going to be x plus 3 squared, because we can just divide this by 2. And that way when we square it, it'll give x squared. These will multiply together and double. And then we need to go back up, and we need to square the binomial to complete the square. So x squared, 6x, and then 3 squared is 9. So we're going to go back up and do 9. But this is where it gets a little bit weird. So square binomial. This looks like a 9, but if I put minus 9 here on the outside, this is wrong. It looks like you are adding 9 and subtracting 9, but that's actually not correct. This isn't really adding 9. It's a 9 in disguise. The 9 is getting multiplied by 2. This 2 is distributing. And so what this really is it's an 18. Because when we factor out the 2, this number that we add in needed to be an 18 to make it be the right binomial. So whenever we factor out a number, we need to make sure we recognize that it's getting multiplied by 9 to make 18. And so we're actually adding an 18 even though it looks like a 9. So we had to do minus 18 here, not minus 9. So it looks kind of like we're adding 9 and subtracting 18, but this 9 is getting multiplied by 2. And so it's adding 18 and subtracting 18. And so just like before, we can combine these like terms and get minus 19. And these are the same functions. In fact, all of these are the same. They just have some in-between steps. So we were able to get it into vertex form by bullying out the y-intercept, factoring out the leading coefficient, completing the square, but recognizing that the number that we added on here isn't really that number. It's getting multiplied, and so we have to subtract the opposite number. Why don't you guys try this one on your own? You might make a mistake. This is a fairly difficult concept until you've practiced it a little bit, and then we'll go over it together if you need it. All right, let's see how you did. First step, you should have bullied out the 1. So m of x equals negative 3x squared plus 24x. We're going to leave room to complete the square, and we're going to bully out the 1. So we're making some room in our group. Next, we needed to factor out the negative 3, sorry. So m of x will equal negative 3 times what? Well, negative 3 times x squared, and negative 3 times negative 8x, because a negative times a negative gives you a positive. So if you factor out a negative, it's going to switch all the signs. The 1 is just chilling out there. These are still equal to each other. I haven't done anything yet. And now I can tell what square binomial this is going to be. This is going to be negative 3. This has got to be x now. And these will multiply together and double to make this. So this is x minus 4 squared. I can go back up and complete the square. To make it be x minus 4 squared, we square the first one, multiply these two together and double it, and then we square the last one. This is plus 16. Now, should I put minus 16 on the outside? No, no, no. This isn't really a 16. It's really a negative 48 because it's really getting multiplied by negative 3. This is minus 48. And so if we subtract 48 on the inside, we actually need to add 48 on the outside. That way they cancel each other out. So it looks a little bit like I added 16 and added 48, but this 16 is really a negative 48 because it's getting multiplied by the 3. And so the last step is to combine these like terms and get plus 49. All right, why don't we try this while doing what we actually want to do, which is to graph this stuff. Go ahead and get this into vertex form. Hopefully we recognize that the first thing we need to do is bully out the 3 to make room to complete the square. Now we can tell what square binomial it is. There's no number in front here that we have to factor out, so we can just go straight to finding the square binomial. This is x plus, this number needs to multiply together and get doubled. So this is going to be a 1. We can just divide by 2. 2 divided by 2 is 1. That way when we multiply them together and double it gets 2x. And we can square the 1 to go back up here to complete the square. So 1 squared, 1 times 1 is 1. And if we add 1 here, we need to subtract 1 here. And so we get it in vertex form. Here is the vertex form, x plus 1 squared plus 2. What's the vertex of this quadratic? Well, this is a transformation, so it's 1 to the left and 2 up. So negative 1, 2. How do we graph it? Well, we're going to put a vertex at negative 1, 2, and then we can make a parabola from here by squaring numbers away from the vertex. So when we're 1 away from the vertex, 1 squared is 1. It'll be the same on both sides. When we're 2 away from the vertex, 2 squared, 2 times 2 is 4. So it'll be 4 up from the vertex. 1, 2, 3, 4. When we're 3 away, it'll be 3 squared is 9, which is 9 up from the vertex. And so we get that nice parabola U shape. One last one, guys. Let's do this. Let's do this one. Go ahead and get it into vertex form. See how you do. And hopefully you recognize that you needed to first bully out the 6 to make room for our square binomial. But this time there's a number in front of the x squared, and so this needs to be factored out. So negative of, the negative of what? Well, negative of x squared is negative x squared, and negative of positive 2x will give us negative 2x. So the negative, when we distribute, will give us the right things there. And now that we have that, we can put it into vertex form. It's going to be negative of what binomial? This is x plus 1 squared, because then when we square the first one, we get x squared. When we multiply these together and double it, we get 2x. And when we square the last one, we'll get 1. So let's go back up and put plus 1 here. Is this really a plus 1? No, because it's getting multiplied by a negative. This was really a minus 1. So we need to add 1 on the outside to cancel it out. So this should be plus 1 plus 6, and so that's plus 7. So where's the vertex? Left by 1, left by 1, up by 7. It'll be at negative 1, 7. So here's our vertex. What does this negative outside do? Well, it reflects it, right? So we're going to do 1 squared is 1, but it gets multiplied by a negative 1. 2 squared is 4, but it gets multiplied by a -1. So we end up with this parabola. All right, guys, hopefully you feel good about this and you'll get some more practice on your homework tonight. This is one of those things, guys, where if you don't practice it, it'll go away very quickly. But if you do practice it, you should get good at it fairly quickly.